Welcome to Wings of Arrow Advanced Education and Research Organization. To know more, visit our official webpage www.wingsofarrow.in. Find your dream aviation and aerospace jobs at www.wingsofarrow.in/jobs. Now we are going to learn about how to find an angle of attack of the supersonic fighter wing relative to the free stream. Consider the Lockheed F-104 supersonic fighter was the first fighter designed for sustained flight at Mach 2. The F-104 embodies good supersonic aircraft design, long slender fuselage, short pointed nose, and a wing with an extremely thin airfoil of 3.4% thickness and a razor sharp leading edge. So short that a protective covering is placed on the leading edge for ground handling. All these features have one purpose: to reduce supersonic wave drag. The planform area of the wing is 18.21 meters square. Consider the case of the F-104 in steady level flight at Mach 2 at 11 km altitude. The weight of the airplane is at its compact weight of 9,400 kg force. Assume that all the lift of the airplane comes from the lift on the wings. That is, ignore the lift of the fuselage and tail. Calculate the angle of attack of the wing relative to the free stream. Given data. Here, the given supersonic fighter flying at Mach M infinity, which is 2, and the planform area of the wing is 18.21 meters square, and the aircraft is flying at an altitude of h, which is 11 km. The weight of the airplane W is 9,400 kg force. Now we have to find out the angle of attack of the wing relative to the free stream. We make the assumption that the lift coefficient of the wing, capital C suffix L, is the same as the lift coefficient for the airfoil section making up the wing, small c suffix L. For subsonic flight, we know that such is not the case. For supersonic flight, such is also not the case. For a straight wing in supersonic inviscid flight, however, the wing tip effects are effectively limited to the region inside the Mach cone with its vertex at the tip leading edge. At Mach 2, the semi-vertex angle of the Mach cone is mu, which is equal to sine inverse of 1/2 is equal to 30 degree. Therefore, much of the wing is unaffected by the tip effects and experiences the two-dimensional flow. The airfoil section of the F-104 is thin and is at a small angle of attack. We conclude, therefore, that linearized theory should be a good approximation for the lift coefficient of the wing of F-104. Thus, we use small c suffix L is equal to capital C suffix L. From linearized supersonic theory, we can write small c suffix L is equal to 4 into alpha divided by square root of m infinity square minus 1, where c suffix L is the lift coefficient of a wing and alpha is the angle of attack and m infinity is the Mach number. From this, we can solve for angle of attack alpha. Then alpha is equal to c suffix L divided by 4 into square root of m infinity square minus 1, where we know m infinity value, which is given in the question. We first calculate the lift coefficient associated with the given flight conditions, recognizing that for level flight, the lift of the airplane must equal its weight. Then we can write c suffix L is equal to W divided by Q infinity into S, where Q infinity is the dynamic pressure. We know Q infinity is equal to 1/2 into rho infinity into V infinity square, where W is the weight of the given aircraft and S is the planform area of wing. Here S is given and the weight is given as 9,400 kg force. This is an inconsistent unit of force. A Newton is the consistent unit of force in the SI system. Since 1 kilogram force is equal to 9.81 Newton, then we have W is equal to 9.212 into 10 to the power 4 Newton. Now calculate the dynamic pressure to find the lift coefficient. As we know, Mach number is the ratio of speed of sound to the speed of vehicle. From this we can write for velocity V infinity is m infinity into a infinity, where m is the Mach number which we know and a is the speed of sound. We know a infinity is equal to square root of gamma into r into T infinity, where r is the gas constant which is 287 joules per kilogram and gamma is the heat capacity ratio which is 1.4. From standard atmosphere properties, at an altitude of 11 km, density rho infinity is 0.3648 kg per meter cube and temperature T infinity is 216.78 Kelvin. Solving with those values, we get A infinity is 295 meter per second and velocity V infinity is 590 meter per second. Now substitute the values of density and velocity in dynamic pressure expression and solve. We get dynamic pressure Q infinity is equal to 6.35 into 10 to the power 4 meter per second. Now we can find the lift coefficient C suffix L. Now substitute W and Q infinity and S values in equation number 2 and simplify. We get CL is equal to 0.08. Now substitute lift coefficient and Mach number in equation number 1 and simplify. We have alpha is 0.035 in terms of radian. In degrees, the wing angle of attack is 1.98 degree. Thus, we get the required angle of attack of the given fighter is 1.98 degree. This is a small angle of attack and clearly satisfies the small angle approximation embodied in linearized theory. This result reflects actual flight conditions of supersonic airplanes, indicates that such airplanes fly at small angles of attack. Did you know the fastest commercial plane flew at twice the speed of sound? The Concorde, which offered flights continuously from 1976 to 2003, traveled at twice the speed of sound. In fact, the supersonic jet, which could achieve speeds up to 1354 miles per hour, also broke a number of world records for its speed. In one case, earning the record for the fastest transatlantic flight when it transported passengers from JFK in New York to Heathrow Airport in London in just 2 hours, 52 minutes and 59 seconds. Airplanes can trigger lightning. When a plane passes through clouds, the static created can actually spur the development of lightning. Fortunately, even if your plane is struck, you are likely pretty safe. There has not been a lightning-related plane crash in the United States since 1963, and increasing safety measures have made lightning strikes less dangerous to passengers than ever before. When lightning strikes a plane, the electrical current is evenly distributed throughout the aircraft's conductive aluminum interior, while grounding the plane's interior electrical system prevents surges that could interfere with its functionality. Pointing a laser pointer at a plane is a serious crime. Drive your pets crazy with a laser pointer all you want, but never aim that annoying red dot at your plane. According to 18 US Code Section 39A, if you point a laser pointer at a plane or its flight path, you can enjoy up to 5 years in prison to think about what you have done.
If you have further inquiry or requested video, drop down to our mail wingsofarrow@gmail.com. Don't forget to subscribe for more updates. For the time being, take care, stay blessed, inspired and fly high.